The silence of the cosmos is never truly empty. Between the stars, beyond the swirling arms of galaxies, past the thin mist of interstellar gas, there exists a stillness that is almost holy, a vast ocean of black, broken only by the pale fire of distant suns. For centuries, humanity has looked into that abyss and called it silence, a void untouched, eternal. But silence is deceptive. Even the most profound quiet hides the murmurs of creation, and on a night not long ago, that silence cracked. NASA's instruments, calibrated to hear whispers fainter than the faintest starlight, detected something that should not exist. It was not a burst like a supernova, nor the lingering hum of a pulsar. It was not gravity-bending space, nor radiation left over from the birth of time. It was stranger, a ripple where no ripple should be, an echo with no voice to make it, a signature that contradicted the very textbooks we believed were unshakable. Imagine standing in a cathedral so vast its walls are lost in darkness. You believe it to be empty, built only of air and stone, and then a single note drifts across the expanse. No musician, no choir, no hand on an organ key, just sound, trembling through silence. That is what this detection felt like to those who saw it appear on their screens. It arrived without warning, no announcement, no gradual build-up. A line of data, a spike where there should have been none, and in that spike was the weight of centuries of questions. The universe, it seemed, was whispering a secret one humanity had not been prepared to hear. The mystery had no name, for it defied categories. Was it a flaw, a mistake in the circuitry of our machines? Was it an echo of something known but mismeasured? Or was it, impossibly, a window into something no human had ever glimpsed, a hidden layer of the universe, humming beneath the skin of reality itself? NASA's scientists stared into the anomaly, knowing that every great revolution in science begins with discomfort, with something that refuses to fit. The silence of the cosmos was broken, and nothing would ever be the same again. The first whispers did not arrive as a grand cosmic trumpet, but as a faint disturbance etched across the screens of NASA's most sensitive observatories, instruments designed to catch dying embers of stars, to listen for ripples in the ocean of space-time, suddenly displayed signatures that should not have been there. At first glance, they looked like noise, the random static that plagues even the most carefully shielded sensors. But when the noise repeated, and when its shape mirrored across different detectors at different times, the suspicion of accident faded. Something beyond Earth was speaking. It began with faint anomalies registered at the edges of deep space surveys. The detectors aboard satellites orbiting far beyond the pull of Earth's atmosphere began returning data that seemed misplaced. Numbers that should have been flat trembled, waves that should have been silent hummed. The engineers combed through the circuits, searching for interference from Earth's own machines. Perhaps a stray signal from communication satellites, perhaps a reflection of solar storms, yet nothing matched. In Pasadena, at NASA's Jet Propulsion Laboratory, researchers compared notes with their counterparts at Goddard and with teams connected to the James Webb Space Telescope. Each group had noticed flickers, faint but consistent. What tied them together was their impossible source, regions of sky where, according to known maps of matter, nothing of significance should exist. The discovery recalled an older memory in astronomy, the detection of the cosmic microwave background in 1965, when Arno Penzias and Robert Wilson mistook the echo of the Big Bang for pigeon droppings on their radio antenna. In the same way, NASA's engineers feared they were chasing phantoms of their own making. But just as Penzias and Wilson discovered the birth cry of the cosmos, these whispers hinted at something larger, a resonance from deep time or deep space that did not belong to any known phenomenon. The whispers had no sound in air, for space is airless. They existed as faint surges in data streams, spikes in graphs, pulses in radio frequencies that should have been smooth, yet to the scientists watching, they carried the gravity of voices. The cosmos, which had seemed silent, had uttered an enigmatic syllable, and so, the data was preserved. Teams began running parallel analyses, stripping away every possible explanation rooted in human error. The whispers were not random. They appeared in patterns too deliberate to ignore, faint arcs across charts that hinted at hidden structures woven through the fabric of the universe. The scientists were not yet ready to call it discovery, but they knew, with unease and anticipation, that they were standing at the threshold of something vast, something the textbooks had not prepared them to see. In every great scientific mystery, there is a moment when one human being, staring at a screen or through an eyepiece, realizes that the world has shifted. For the whispers in the data, that moment belonged to a handful of scientists working late into the night, eyes bloodshot, driven not by curiosity alone but by the quiet dread that they were glimpsing something that should not exist. Among them was a young astrophysicist, assigned not to seek the extraordinary but to verify the mundane. Her role was to comb through raw data for errors, to catch glitches before they bloomed into headlines. And yet, as she filtered the latest signals, she noticed the pulse recur in different slices of sky, faint, fragile, but repeating. It was like listening for silence and hearing the same note return, played softly on an unseen instrument. She was not the first to see it, but she was the first to insist. This is not noise. Her report, sent quietly to senior colleagues, was met with skepticism. Experienced astronomers had been fooled before cosmic rays striking a detector, thermal variations mimicking signals, or, most humiliating of all, human interference bleeding into sensitive instruments. But when the data was cross-checked across independent observatories, the pattern held. Different telescopes, different nights, different instruments, and yet the same inexplicable anomaly appeared. The discovery did not begin with a press release or a conference. It began with hushed conversations in hallways, with meetings called in dimly lit labs, with whispers among scientists mirroring the whispers from the stars. They knew the responsibility that came with such anomalies, the danger of false hope, the humiliation of error, the skepticism of peers. And yet, beneath the weight of doubt, there was also awe. For if this signal was real, if it was not an artifact of their machines, then they had uncovered a phenomenon that reached across the void, untouched by human hand, woven into the structure of the cosmos itself. The sleepless nights multiplied. Computers ran simulations, trying to match the data to known sources: pulsars, quasars, gamma-ray bursts, gravitational waves. Nothing aligned. Each test excluded more possibilities. Each result deepened the mystery. And so the young scientist, once tasked with finding mistakes, became the keeper of a secret so fragile that even speaking of it aloud felt like tempting fate. She wrote in her notebook that night, a simple line echoing the thought that haunted every member of the team: "The universe is trying to tell us something. But what?" The first rule of science is skepticism. When the anomaly persisted, when it refused to vanish under scrutiny, the reaction of the scientific community was not wonder but resistance. It contradicted what the textbooks had laid down as bedrock. Every equation, every model of cosmic behavior had carved the universe into a structure of predictable patterns. The stars obeyed gravity. The galaxies stretched with expansion. Radiation echoed the ancient fire of the Big Bang. Everything fit until now. The signal they had uncovered did not belong to any catalogued phenomenon. It pulsed where silence should reign. It carried strength across distances where energy should have dissipated. According to classical physics, it should not exist. According to relativity, it should not persist. And yet, there it was, etched in data, too consistent to ignore. To scientists trained in the language of certainty, this was terrifying. Physics thrives on predictability. A falling apple, a bending beam of light, a planet in orbit, all dance to rules that can be written on paper. The anomaly danced to no rule at all. It appeared like a shadow against the order of things, an uninvited guest at the banquet of the cosmos. The contradiction cut deep. If it were a new type of star, it should reveal a spectrum. If it were a galaxy's distant flare, it should align with visible structures. If it were a gravitational wave, its rhythm should mirror the merger of massive objects. But none of these fit. The anomaly existed outside classification, as if mocking human attempts to name and file it. The shock was not merely scientific, it was existential. For if the universe could produce phenomena beyond every law we know, then how fragile were those laws? How limited were the frameworks that guided centuries of human thought? The textbooks did not tremble because of an error. They trembled because something vast and unknown pressed against the edges of knowledge, demanding entry. In hushed meetings, senior physicists admitted the unthinkable, that they might be facing the kind of discovery that forces the rewriting of physics itself. The kind of finding that once made Newton yield to Einstein, and Einstein to quantum theory. A moment when certainty dies, and mystery takes its place. The anomaly was not simply strange, it was heretical. When the anomaly refused to dissolve under scrutiny, the scientists widened their gaze. They pointed telescopes not to a single corner of the heavens but to regions scattered across the sky, searching for echoes of the same elusive signal. What emerged was unsettling. The phenomenon was not isolated. It repeated, faint yet insistent, in places separated by billions of light years. It was as if the universe itself was stitched with a hidden thread, weaving across galaxies, tugging faintly at the fabric of space-time. The maps began to fill with dots, each marking a detection. At first, they appeared random, scattered across the cosmos like meaningless noise. But with patience and precision, patterns arose. The pulses seemed to cluster along vast cosmic structures, the same filaments of dark matter that form the skeleton of the universe. Could it be coincidence, or was this anomaly bound to the unseen framework that holds galaxies in their silent embrace? For decades, astronomers had drawn the cosmic web strands of matter stretching across the universe, galaxies strung like beads along invisible lines. The anomaly seemed to echo this map, humming faintly in the very same corridors of emptiness. Yet where gravity explained the galaxies, nothing explained this signal. It was as though the voids themselves were speaking. As more observatories contributed data from Chile's desert to Hawaii's volcanic peaks, from orbiting satellites to balloon-borne detectors, the picture grew sharper. The whispers were not local quirks. They belonged to the universe itself. Even more unsettling, the strength of the signal did not fade with distance as expected. Instead, it sometimes seemed louder when traced farther away, as though the darkness itself amplified it. The scientists, who once suspected faulty instruments, now faced a deeper unease. The cosmos was not only stranger than they had imagined, it was stranger in a way that suggested design. The echoes mapped onto structures too vast, too deliberate, to dismiss as chance. Each new detection was both triumph and burden, a deeper step into mystery. What had begun as a blip in data had grown into a chorus, stretching from one edge of the universe to the other. And with every new point plotted, the question sharpened. Was this a signal from something woven into the birth of the cosmos, or was it the footprint of a force still unfolding, reshaping reality in silence? Doubt is the heartbeat of science, and with each new detection, doubt grew sharper. Could the instruments themselves be conspiring to produce an illusion? Could a hidden flaw, a sliver of miscalibration, a ghost of interference mimic the grandeur of cosmic mystery? The scientists were relentless in asking these questions, for to leap too quickly into discovery is to risk error that reverberates through generations. Entire teams devoted themselves to dismantling their own work. Engineers stripped detectors to their bones, searching for microscopic faults. Software was rewritten line by line, algorithms tested against oceans of artificial noise to see if the pattern might arise by chance. Data from satellites orbiting Earth was compared to readings from ground-based observatories half a world apart, separated not only by distance but by atmosphere, climate, and electromagnetic environment. If a flaw existed, it would have to defy the diversity of machines and methods that all pointed to the same whisper. And yet, after months of dissection, the anomaly remained. Like a ghost refusing to be exorcised, it returned in every dataset, no matter how carefully filtered, no matter how ruthlessly challenged. Some began to speak of it with unease, calling it the shadow of uncertainty, a phrase that captured both its elusiveness and its persistence. The shadow haunted the scientific imagination, for while most anomalies collapse under scrutiny, this one seemed to thrive upon it. The more carefully it was studied, the more it insisted on being real, and the more it resisted dismissal, the more dangerous it became. Because if the anomaly was genuine, it demanded explanations that physics was not yet equipped to provide. Some senior physicists urged caution, recalling infamous errors of the past, the discovery of canals on Mars that proved to be optical illusions, the announcement of faster-than-light neutrinos later undone by a loose cable. They warned against premature conclusions, against building theories upon mirages. But the younger researchers, who had grown up in the age of precision cosmology, pushed back. Never before had instruments been so finely tuned. Never before had so many independent detectors whispered the same impossible story. The atmosphere in conference halls shifted. What had begun as an embarrassment, an oddity to be eliminated, now became a presence that could no longer be ignored. The universe, it seemed, was insisting upon its mystery. When human doubt reaches its limits, the only refuge is to look deeper. And so, the eyes of science turned with greater intensity toward the heavens. Satellites were commanded to reorient, their instruments trained on coordinates where the anomaly had sung before. Ground-based telescopes, some built for mapping galaxies, others for chasing the faint glow of ancient starlight, were enlisted into the search. It was no longer a side project, no longer a curiosity. It had become an inquiry into the heart of the unknown. The Hubble Space Telescope, though aging, lent its clarity. The James Webb Space Telescope, with mirrors wide as a house and instruments cooled to near absolute zero, joined the pursuit. Radio observatories spread across deserts, their dishes like listening ears scanned the sky. The Atacama Large Millimeter Array, perched high on the Chilean plateau, sifted through faint waves invisible to the human eye. Each became part of an orchestra, tuned to hear the faintest vibration in the cosmos. What they found did not simplify the riddle. The anomaly was not a singular event, not a rare cosmic coincidence. It appeared in places where nothing should happen, in the cold voids between galaxies, in the silent stretches of blackness that theory predicted to be barren. Even more unsettling, the whispers seemed to vary with time, pulsing stronger on some nights, fading on others, as though the cosmos were breathing. The deeper they probed, the more layered the mystery became. In some regions, the anomaly seemed tied to gravitational wells, as if lurking at the edges of galaxy clusters. In others, it shimmered in the emptiness, unattached, like a voice with no body. The scientists could not agree whether they were seeing the trace of matter unknown or the trembling of space itself. The search carried them farther into the void. Beyond the familiar galaxies, beyond the maps of known stars, they ventured into the wilderness of the observable universe, a wilderness where time itself stretches thin, where the light they see began its journey billions of years before Earth was formed. And still, the anomaly persisted, written into that ancient light as if it had always been there. The instruments had done their work faithfully. The deeper the gaze, the louder the riddle became. What had begun as a whisper now resounded as a haunting murmur across the cosmos. Science had turned its eyes into prophets, but the prophecy was unclear. Was this the birth cry of something new, or the death rattle of a universe unraveling? The further they searched, the less sense it made. The expectation had been that clarity would emerge with more data, that the fog of uncertainty would lift under the weight of observation. But with every new measurement, the mystery only grew. Instead of dissolving, it multiplied. What began as an isolated whisper had become a riddle woven into the fabric of the universe itself. The anomaly showed a habit of contradiction. In one region, it aligned faintly with clusters of galaxies, as though tied to the gravity of massive structures. In another, it drifted in the voids between them, where there should have been nothing at all. In some detections, it seemed stable, constant across long stretches of time. In others, it flickered unpredictably, swelling and fading like a candle in an unseen wind. This inconsistency should have broken the case. Science thrives on order, on reproducibility, on rules that bind. But here was something that obeyed no single pattern and yet resisted dismissal. Like a puzzle whose pieces belonged to different pictures, the anomaly defied any effort to assemble it into coherence. For the researchers, the effect was unsettling. Their instruments were not malfunctioning, of that they were increasingly certain. What troubled them more was the possibility that the anomaly was not a single phenomenon at all, but a glimpse into multiple layers of reality, overlapping in ways too complex for the human mind to easily untangle. The meetings grew tense. Senior physicists spoke in hushed voices of paradigm-breaking implications, of forces outside the standard model, of hints that space-time itself might be more unstable than anyone had imagined. Younger scientists, unburdened by decades of certainty, spoke openly of quantum fields whispering through the void, or of dimensions brushing against our own. None of these theories fit neatly, but all carried the same undertone. We are staring into something that does not belong in the world we thought we understood. Each new dataset confirmed the same paradox. The closer the scrutiny, the stranger the anomaly became. Instead of resolution, escalation. Instead of answers, questions without end. The mystery had shed its disguise. It was no longer a background noise to be dismissed, but a presence that demanded to be reckoned with. And as the weeks turned into months, a darker realization emerged. If this anomaly grew stronger the further we looked, what would it reveal when we reached the edges of the cosmos itself? For more than a century, Einstein's equations had been the compass guiding humanity through the labyrinth of the cosmos. Relativity had rewritten the heavens, showing that space could curve, that time could bend, that gravity was not a force pulling bodies together but the geometry of reality itself. Every satellite, every GPS signal, every black hole image stood as testimony to the truth of his vision. And yet, before this anomaly, even Einstein's elegant mathematics began to tremble. When scientists attempted to map the strange signal into the framework of relativity, the numbers broke apart. Space and time, as described by Einstein, could not accommodate what the data implied. The anomaly hinted at accelerations where no mass was present, at ripples where no energy source could be found. According to relativity, such behavior was impossible, but the universe was not obliged to obey the limits of human equations. Some physicists whispered of a deeper layer beneath relativity, the way relativity itself had once lain hidden beneath Newton's mechanics. Perhaps Einstein's vision was incomplete, not incorrect, but part of a grander whole, one that humanity had yet to glimpse. If so, then the anomaly might be the crack in the wall, the first fracture that revealed a hidden structure beneath the familiar architecture of physics. Others resisted. Relativity had withstood every test, from the bending of starlight during eclipses to the delicate dance of binary pulsars, to the detection of gravitational waves a century after Einstein predicted them. To question relativity was to question the very spine of modern science. And yet, the data lingered, indifferent to human reluctance. The discomfort deepened with every calculation. The anomaly suggested movements in space-time with no cause, as though the universe itself could accelerate from nothing, conjuring momentum from emptiness. If true, this would unravel the principle of energy conservation, one of the most sacred laws in all of science. Einstein's equations, beautiful and enduring, were not enough, and so the name of Einstein was invoked not in reverence but in challenge. Just as Newton had yielded to him, perhaps the time had come for relativity to bow before something greater. What that something might be, no one could yet say. But the anomaly had spoken a dangerous truth. Even the greatest equations are only shadows on the wall of a deeper mystery. The first whispers had unsettled. The contradictions had alarmed. But what came next terrified. When the anomaly was plotted against distance, the further away the source, the more ancient the light, a chilling revelation emerged. Instead of fading with remoteness, instead of dissolving into silence, as all ordinary signals should, the anomaly grew stronger. The deeper into the cosmos the scientists looked, the louder the whisper became, as though the universe itself was amplifying its secret. This was not how reality was supposed to behave. Radiation weakens with distance, gravity softens as mass spreads thin, entropy ensures that order collapses, that structures dissolve into randomness. But here was a signal that defied entropy, that seemed to swell, as if nurtured by the very fabric of space-time. It was as though the cosmos were breathing harder the further back in time humanity gazed. The term many began to use was haunting acceleration, not the acceleration of galaxies fleeing each other that was already known, the great discovery of dark energy. This was stranger still, a pulse in the void that intensified across distance, echoing more fiercely the closer one approached the boundaries of the observable universe. It was not just expansion, it was a deepening vibration, a silent scream written into the stars. The implications were staggering. If the anomaly was truly stronger at cosmic scales, it might not be a local disturbance at all, but a fundamental property of the universe, woven into its birth and its future. Could it be a new form of energy, one that grows as space itself grows? Could it be evidence that the acceleration of the cosmos was not a feature of galaxies alone, but of the very ground of reality? Some speculated that the anomaly could be linked to dark energy itself, the invisible force that drives galaxies apart. But if so, then this was not the smooth, uniform dark energy cosmologists had imagined. This was something restless, flickering, almost alive. And so, the mystery deepened into dread. For if the anomaly grew with distance, then it also grew with time. The further ahead the universe marched, the stronger this presence would become. What would happen then, when it reached a threshold too great to contain? Was it a herald of transformation, or of collapse? The haunting acceleration did not offer answers. It offered only a warning. The further we look, the stranger the universe becomes. The human mind abhors chaos, and so, even in the presence of the inexplicable, scientists reached instinctively for theories. To leave the anomaly nameless, shapeless, was to surrender to fear. To craft explanations, however fragile, was to reclaim a measure of control, and so, from chalkboards covered in equations to computer models running day and night, the first theories began to take form. Some argued it might be the echo of cosmic structures too faint to see ancient filaments of matter stretching across unimaginable scales, their hidden presence revealed only through these subtle pulses. Perhaps what the telescopes were hearing was the heartbeat of the cosmic web itself, vibrating faintly like strings plucked in a dimension beyond ordinary sight. Others turned to more radical ideas. Could this be a new kind of field, an unseen force permeating the universe? Not dark matter, which clings invisibly to galaxies, but something stranger, an ocean of energy humming quietly between stars, stirring only when measured on vast scales. Still others suggested that the anomaly might be the trembling of spacetime itself, a kind of background vibration not predicted by relativity. If so, it could represent a new category of phenomenon, a cosmic weather, born not from stars or galaxies but from the geometry of the universe itself. None of these theories fit perfectly. Each explained part of the data but failed to embrace the whole. The whispers aligned with structures in some regions but not in others. They grew stronger with distance, but not in a uniform way. They flickered as if alive, defying simple models of steady cosmic forces. And yet, within the imperfect theories was a shared conviction. This was not an error, not a ghost of faulty instruments. It was real. The universe was speaking, though in a language humanity had not yet learned to translate. The first papers were written, careful and restrained, their language technical but their undertones trembling with awe. Phrases such as unexplained anomaly and requires further study concealed the truth. The scientists did not know what they were facing, but in the quiet of their minds and in the long nights staring at data, they knew they were standing at the edge of discovery, a precipice that might reshape not only science, but the human understanding of existence itself. As theories multiplied, one rose above the rest, casting its shadow across every conversation, every late-night debate. The anomaly, some argued, might be the echo of dark energy itself, that invisible, unfathomable force first proposed to explain why galaxies flee one another faster and faster, why the universe refuses to slow but instead accelerates in its expansion. Dark energy had always been a ghost. It could not be seen, could not be touched, could not be pinned down to any particle or field within the standard model of physics. Its only evidence lay in the motion of galaxies, the stretching fabric of space-time. Astronomers had measured its fingerprints, but they had never glimpsed its face. And now, in the trembling of the anomaly, some believed they had finally heard its voice. The idea was haunting in its elegance. If dark energy were not uniform, as once assumed, but restless, fluctuating, pulsing in ways invisible until seen at the grandest scales, then perhaps this was what the telescopes had caught, the hum of the cosmos expanding, the subtle vibration of the universe's own lifeblood. The anomaly, in this view, was not an error, but a revelation, the first direct encounter with the very substance that will decide the fate of all things. But such an explanation carried both wonder and terror. For if the whispers were indeed dark energy, then they revealed a truth far stranger than the neat equations cosmologists had hoped for. Instead of a smooth, silent pressure pushing galaxies apart, dark energy might be a volatile sea, shifting unpredictably. It might not only accelerate the cosmos, but reshape it, alter its destiny in ways no theory could yet predict. Skeptics pointed out that dark energy had always been inferred, never measured. To tie the anomaly to it was to lean on the weak shoulders of speculation. Yet, for many, the connection was irresistible. In the ghostly pulses across the void, they felt the presence of the universe's hidden engine, whispering at last after eons of silence. And so, the ghost energy theory took hold. In conference halls and research papers, scientists spoke cautiously of variable dark energy or dynamic vacuum energy. But beyond the careful words, a deeper thought took root. If this was truly dark energy made manifest, then humanity was not merely listening to a signal. It was listening to the heartbeat of the cosmos itself, a heartbeat that might one day falter. If the whispers in the void were not simply a song of dark energy, then perhaps they were something far more precarious, the faint trembling of reality's own foundation. A few daring voices in the physics community began to suggest a possibility both elegant and terrifying: false vacuum decay. In quantum field theory, the vacuum of space, what we casually call emptiness, is not truly empty. It is alive with fluctuations, fields bubbling invisibly, virtual particles flashing in and out of existence. What we call the vacuum is really a kind of stage upon which the laws of physics are written. But what if that stage is unstable? What if the universe we inhabit is balanced not in the true ground state of reality, but in a fragile, temporary one, a false vacuum? The anomaly's restless pulse, its refusal to fit into familiar laws, reminded some of the theoretical signals expected if the universe were perched in such a precarious condition. In this scenario, the cosmos exists like a ball resting in a shallow valley, stable only by chance. One push, one quantum fluctuation, one hidden instability, and it could tumble into a deeper valley, rewriting the laws of physics in an instant. The horror of false vacuum decay lies in its indifference. If it occurs, it would spread outward at the speed of light, transforming everything in its path. Atoms, forces, even the structure of space-time itself would dissolve into a new reality, alien and unrecognizable. There would be no warning, no escape. One moment we would be here. The next, the laws of nature would be rewritten. Could the anomaly be the whisper of such instability? Could it be a vibration in the very field that defines reality? A warning that the ground beneath existence is thinner than we thought? The idea chilled even those who proposed it. To entertain such a possibility was to stare into a void deeper than any telescope could reach. Most dismissed the speculation as premature, even reckless, and yet, in the quiet of their offices, some physicists admitted the thought lingered. The universe has lasted nearly 14 billion years, but longevity does not mean permanence. Perhaps the anomaly was not only a scientific riddle, perhaps it was the faint shiver of a universe holding together by chance, waiting for the moment when the fragile illusion of stability finally gives way. As the anomaly deepened in mystery, one idea returned again and again, whispered not only in laboratories but in late-night conversations among physicists. What if this signal does not belong to our universe at all? The thought was not new. The concept of a multiverse, countless universes existing side by side, each with its own laws and constants, had long haunted cosmology. Some theories of inflation, the rapid expansion after the Big Bang, predicted that our cosmos might be just one bubble among an endless foam of others. Normally, such speculation remained philosophical, untestable, but the anomaly gave the idea new gravity. If the whispers did not match anything in our universe, perhaps they were the fingerprints of another, brushing against ours at the edges of existence. The faint pulses might be the scars of collisions long past, when our universe expanded beside neighbors that left behind subtle imprints in the cosmic fabric. Or perhaps they were ongoing, a constant bleed of information, like static leaking across the walls between worlds. The idea unsettled as much as it inspired. If true, it meant that the cosmos we call home was not unique, not absolute. The laws of physics we revere could be local customs, arbitrary rules of our bubble, with others out there shaped by constants entirely alien. Gravity might be stronger in one, weaker in another. Time might flow differently. Even life, if it could exist, might follow forms we cannot imagine. Some models of the multiverse predicted exactly such anomalies, faint alignments in cosmic background radiation, or unexplained signals in deep surveys. Could the anomaly be confirmation at last? Could it be the first empirical whisper that we are not alone in the cosmic foam? Yet the thought also carried dread. If universes can collide, what would it mean if ours met another? Would the meeting be gentle, like ripples overlapping in water, or violent, rewriting the very fabric of our existence in a flash? The whispers from the anomaly did not answer these questions, but they gave them weight. What was once speculation now shimmered with possibility, and in the silence of conference halls, as equations sprawled across blackboards, some physicists allowed themselves to imagine that the anomaly was not only a scientific puzzle, it was a message from beyond, a reminder that reality may be far vaster, far stranger, than the fragile bubble of space-time we call home. If the whispers were not from beyond our universe, perhaps they arose from something more intimate, more fundamental. The restless fluctuations of quantum fields themselves. Beneath every particle, beneath every atom, beneath the forces that sculpt galaxies, there exists an invisible sea, the quantum fields. They are not objects but presences, abstract yet real, filling all of space-time. Each particle we know, from electrons to quarks, is but a ripple in one of these fields. They are the hidden stage upon which reality performs its endless play. For decades, physicists had believed they understood the vacuum of these fields, quiet, stable, and equilibrium. But the anomaly hinted at another truth, that the vacuum might not be silent after all. Perhaps it was humming, oscillating, restless in ways too subtle to notice, until the instruments of our age grew sensitive enough to hear it. The pulses detected by NASA and its collaborators bore a resemblance to what some theorists had long speculated: vacuum fluctuations magnified to cosmic scales. Normally, such fluctuations cancel out, leaving no lasting trace. But what if, in the deep architecture of space-time, they resonated instead? What if the very emptiness of the universe was vibrating like the skin of a drum, producing echoes that no known law could predict? The implications were staggering. If the anomaly was indeed the awakening of quantum fields, it might bridge the gap between the physics of the very large Einstein's relativity and the physics of the very small quantum mechanics. For a century, those two pillars had stood side by side, powerful but irreconcilable. The anomaly might be the crack where they begin to converge. Some saw beauty in this possibility. The universe itself would then be alive with hidden rhythms, its silence merely an illusion. Every patch of darkness, every stretch of emptiness, would be vibrating with potential, humming faintly with the memory of creation. Others saw danger. If quantum fields could stir on such scales, they might also destabilize, sending ripples that could alter the balance of forces holding matter together. The whispers of the anomaly became, in this view, not the voice of a neighboring universe, nor the ghost of dark energy, but the breath of reality itself, quantum fields awakening in ways we had never dreamed. And for the first time, humanity stood at the edge of hearing the universe not as a machine of particles and forces, but as a living sea of vibrations, resonant, mysterious, and endlessly deep. To chase the anomaly further, science called upon its greatest oracles, the telescopes that had become humanity's eyes on the infinite. Each one, a sentinel of glass and metal, floated or perched in silence, yet carried the power to transform mystery into knowledge. If the whispers were real, they would leave traces in light, in radiation, in the faintest shimmer of the cosmos, and telescopes were the tools to capture them. The Hubble Space Telescope, whose mirrors had already revealed the birth of galaxies, was retasked to stare into regions of apparent emptiness, where the anomaly had whispered loudest. Its sharp eye returned images filled with stars, but nothing that could explain the pulses. Still, subtle alignments in the distribution of galaxies hinted at patterns, filaments of matter glowing faintly, as though illuminated by something unseen. Then came the James Webb Space Telescope, poised beyond the warmth of Earth's atmosphere. Its golden mirrors stretched wide like a flower drinking starlight. Webb peered deeper, further, into the infrared glow of the earliest galaxies. Its instruments recorded spectra that carried slight, inexplicable distortions, as if the very light from ancient stars had been nudged by a hidden hand during its billion-year journey. On Earth, radio observatories joined in chorus. The square-kilometre array, still rising in the deserts of South Africa and Australia, promised to map the sky with unprecedented sensitivity. Even before its full array awakened, early prototypes captured faint radio structures aligned suspiciously close to the regions where the anomaly sang. And from Antarctica, neutrino detectors buried deep in ice searched for ghostly particles that might accompany the whispers. None were found, and that absence itself deepened the riddle. For if the anomaly carried no particles, only waves, then it might indeed be rooted in space-time itself. Scientists began to speak of their telescopes as prophets. Each returned fragments of scripture, incomplete yet profound, verses in a language not yet translated. The anomaly seemed to weave itself into every wavelength, every corner of the sky, and yet never revealed its full face. It was as though the cosmos were determined to be known only in fragments, offering just enough to stir awe, never enough to quench it. And so, the telescopes, Hubble, Webb, radio arrays, and more to come, became not just instruments of science, but instruments of prophecy, straining to catch the rhythm of a universe whose silence was now known to be filled with hidden song. If telescopes were the eyes of the search, then particle colliders were its microscope's instruments that peered not outward into the heavens, but inward into the invisible gears of reality. Where the anomaly stretched across billions of light-years, colliders sought its echo in the tiniest collisions, smashing protons together to glimpse the fabric from which the cosmos is woven. At CERN, the Large Hadron Collider continued its search, Once it had revealed the Higgs boson, the long-predicted particle that gave mass to matter. Now, physicists turned their gaze towards subtler possibilities: fluctuations in quantum fields, deviations in particle behavior, hints that might mirror the whispers NASA's instruments had caught in space. If the anomaly was tied to dark energy or false vacuum instability, its fingerprints might be found in high-energy experiments, written in the scattering of particles or in energies that seem to vanish without explanation. So far, the results were ambiguous. The collider detected tiny irregularities, subtle deviations in the expected curves of data. Were they evidence of new physics, or simply the natural noise of experiments pushed to their limits? The uncertainty mirrored the cosmic puzzle. Everywhere the anomaly appeared, it refused to settle into clarity. Beyond CERN, other colliders joined the effort. The relativistic Heavy Ion Collider in New York probed conditions resembling the first microseconds after the Big Bang, when quantum fields surged with unimaginable energy. In Japan, the Super KEKB accelerator hunted for asymmetries in matter and antimatter, phenomena that might whisper of new forces. Each sought, in its own way, to find a terrestrial echo of the cosmic murmur. The irony was striking. In the silence of space, and in the violence of colliders, the same question haunted humanity: was there an unseen energy threading reality together, invisible yet undeniable? If the anomaly was more than cosmic coincidence, then it was not only in the heavens, it was here, in every particle, every atom, woven into the essence of existence. For the scientists working long nights beside humming machines, the pursuit was philosophical as much as practical. If the anomaly appeared both in the sky and in the particle beam, then perhaps the boundary between the cosmos and the quantum was dissolving. Perhaps the whispers were telling a single story, that the very large and the very small, once thought separate, are bound by a deeper truth humanity has only begun to hear. Long before the anomaly was detected, the cosmos had already left humanity a message. The cosmic microwave background, the faint afterglow of the Big Bang, this relic light, stretched thin by nearly 14 billion years of expansion, had been mapped in exquisite detail by satellites like COBE, WIMAP, and Planck. Its tiny fluctuations told the story of the universe's birth, its growth, its composition of matter, dark matter, and dark energy. For decades, cosmologists treated it as the ultimate archive, a frozen fingerprint of creation itself. But now, the whispers from NASA's instruments cast doubt upon even this most sacred of relics. When the anomaly was cross-checked against maps of the cosmic microwave background, strange alignments emerged. Subtle distortions, long dismissed as statistical quirks, began to look suspiciously like cousins of the new signals. The same regions of the sky that pulsed with unexplained energy also seemed to host faint imprints in the background radiation, as if the newborn universe had already carried the seeds of this riddle. The thought was unnerving. If the anomaly was inscribed in the cosmic microwave background, then it was not a recent phenomenon, not a quirk of modern space or present-day physics. It was ancient, as old as time itself. Perhaps the very first moments after the Big Bang had encoded a vibration into space-time, a resonance that survived the ages, whispering still through the silence of the void. Scientists returned to the Planck data, to the old WMAP archives, reanalyzing them with sharpened eyes. Some patterns appeared clearer than memory recalled: asymmetries that did not belong, alignments that stretched across the sky in defiance of randomness. Others remained ambiguous, uncertain, like shadows glimpsed at the corner of vision. For some, this was confirmation. The anomaly was not new, it was primordial, it was written into the blueprint of creation. For others, it was unsettling. If the universe had carried such a whisper since its birth, then perhaps it was not a message at all, but a flaw, a scar in reality, present from the beginning, destined to remain unanswered. The cosmic microwave background had once been thought of as the final word on the origins of the universe. Now, it seemed less like an ending than a prelude, a faint overture whose music we had only just begun to hear. And in that overture, hidden deep in its static, the whispers of the anomaly resonated, waiting to be understood. If the anomaly was not born from galaxies or stars, nor written only in the microwave glow of the early universe, then perhaps it was rooted in the very force that shapes all motion: gravity. For centuries, gravity had been seen as a faithful servant, guiding planets in their orbits, curving light around stars, sculpting the great structures of the cosmos. But as scientists pressed deeper into the mystery, whispers arose of a darker possibility that gravity itself might be betraying us. Modified theories of gravity had long haunted the edges of cosmology. Some argued that what we call dark energy was not a substance at all, but the symptom of a deeper flaw in our understanding of gravity. Perhaps Einstein's vision, though brilliant, was incomplete. Perhaps space-time does not bend precisely as relativity demands. If so, the anomaly might not be a new force whispering through the void, but gravity itself, faltering in its obedience to known law. Data lent unsettling weight to this thought. The pulses often appeared near massive structures, clusters of galaxies, superclusters, bound together across billions of light-years. Gravity should have been predictable in these regions, but instead it wavered, as though the strength of the force shifted subtly depending on distance or scale. Some maps suggested that gravity weakened faster than expected, others that it stretched further, as if tugged by hidden strings. Alternative theories rose to prominence. Modified Newtonian dynamics, once dismissed as fringe, found new relevance. Tensor vector scalar gravity, if, theories, and even more exotic proposals were resurrected, each offering a way to bend the rules of attraction to account for the anomaly. None were perfect, but each carried the same unspoken implication, that the cosmos might not be bound by the simple elegance Einstein had gifted us. To imagine gravity betraying its role was to question everything. Galaxies hold their stars through its pull. Planets trace their paths because of its embrace. Black holes exist because gravity collapses matter into infinity. If gravity itself wavered, then the stability of the cosmos was fragile, conditional, uncertain. The whispers of the anomaly might, then, be the groan of a universe whose very foundations were shifting, not the echo of an intruding force, but the confession of gravity itself, bending in ways we had never dreamed. As more maps were drawn and more measurements returned, a sobering pattern emerged. The anomaly seemed to echo the same riddle that has haunted cosmology for decades, the endless expansion of the universe. Astronomers had long known that galaxies drift apart, pulled not by motion through space but by the stretching of space itself. In the 1,990 seconds, the shocking revelation came. Not only was the universe expanding, it was accelerating. Something unseen, something vast, was pushing the cosmos outward faster and faster. Dark energy was the placeholder name, but the truth remained unknown. Now, the anomaly seemed to deepen this enigma. The signals did not merely align with expansion, they appeared to grow in resonance with it, as though the same hidden force that drives galaxies apart was also vibrating through the void. The further away the scientists looked, the deeper back in time, the stronger the pulse became, as if the expansion itself were amplifying the mystery. This was no coincidence. The anomaly and cosmic acceleration were intertwined. The whispers might be the song of expansion, the subtle music of space-time stretching beyond comprehension. Yet they were discordant, irregular, unlike any model of dark energy once proposed. Instead of a smooth, featureless push, this was a restless presence, a fluctuating tide. The thought carried both awe and dread. If the anomaly was bound to expansion, then it was not just a scientific puzzle, it was the very fate of the universe made audible. Expansion would not stop, it would not slow, it would continue, endlessly, driven by a force that science could not tame, could not predict, could not control. And if the whispers grew louder with distance, then they also grew louder with time. The future of the cosmos might not be silence, but an accelerating crescendo, a deepening vibration until stars drift so far apart that even light itself cannot bridge the darkness. The anomaly, in this vision, was not just a riddle, it was a prophecy that the universe will not end in collapse, nor in fire, but in a quiet, unrelenting, unbinding galaxies receding into eternal night, the cosmos unraveling into solitude, while the whispers swell like the last hymn of existence. The anomaly's unsettling persistence called forth the memory of voices no longer alive to witness it among them. Stephen Hawking. His work had long dwelled on the fragile balance of the universe, the uneasy marriage between relativity and quantum theory, the lurking instability hidden in the fabric of space-time. Though Hawking never saw this specific signal, his warnings seemed to echo through every discussion it inspired. Hawking had spoken often of vacuum instability, of the possibility that what we call reality might rest on a temporary plateau. He warned that the Higgs field itself, the same field that grants mass to matter, might be metastable. poised precariously between survival and collapse. One small nudge, he argued, could trigger a chain reaction that rewrites the laws of physics in an instant. The whispers from the anomaly carried the same dread. If they were not dark energy, not modified gravity, not the bleed of another universe, then perhaps they were the faint trembling of a fragile cosmos, the same fragility Hawking had feared. To consider this was to feel the weight of his warnings, that the universe is not guaranteed permanence, that its very fabric could unravel without notice. But Hawking also carried a voice of paradoxical reassurance. In his reflections, he reminded us that while the universe is fragile, it is also ancient. 14 billion years have passed without collapse. Stars have lived and died, galaxies have collided and reformed, and through it all the cosmos has endured. If the vacuum is unstable, then perhaps its instability is stretched across timescales so vast that human anxiety is a flicker against eternity. Still, his presence lingered in every equation, every speculation. The anomaly forced physicists to revisit his work, to weigh once again the possibility that the universe is both magnificent and precarious, both eternal and fleeting. And in the quiet between calculations, some could almost hear Hawking's voice, calm, reflective, tinged with humor, reminding them that to study the cosmos is always to walk a knife's edge between wonder and terror. The whispers seemed to embody that knife's edge. They might prove to be nothing more than a new field, a new force, another chapter in physics. Or they might be confirmation of Hawking's most haunting warning, that our universe is a temporary sanctuary, holding together only by grace, destined one day to give way to something utterly unknown. Predictions of cosmic doom have haunted science for centuries. Ancient myths spoke of fire and flood, of endings written in the stars. Modern cosmology speaks of heat death, the big crunch, the big rip. Each is a vision of finality, and each is born of mathematics projected across impossible timescales. The anomaly, with its haunting acceleration and inexplicable persistence, seemed to join this chorus. Yet as terrifying as its implications might be, it carried with it a paradox, the collapse that never comes. If the whispers were truly signs of instability, of false vacuum decay, of quantum fields trembling on the edge, then the end should be inevitable, swift, absolute. A bubble of new physics should have swept across existence long ago, erasing everything we know. And yet here we are, galaxies intact, atoms still obeying familiar laws, life unfolding on a fragile blue planet. If collapse is written into the fabric of the cosmos, why has it not come? Some physicists argue that probability itself is the answer. Quantum fields, they remind us, live in a haze of uncertainty. Instability does not guarantee collapse, it only allows for the chance. The fact that the universe persists may simply mean that it exists in one of the rare threads of possibility where disaster has not yet arrived. Others suggest that if collapse did occur, we would never know, we would vanish into new laws in an instant, without awareness, without memory. Our very survival could then be an illusion of timing. But another interpretation emerged from the anomaly itself. Perhaps the whispers are not warnings of imminent destruction, but signs of a tension that has always existed, a strain in the fabric of space-time that can persist indefinitely without breaking. Like a violin string drawn too tight yet never snapping, the cosmos may hum forever on the edge of instability, vibrating with a precarious balance that is both fragile and enduring. This thought was at once comforting and unsettling. It suggested that humanity's fears of sudden doom may be misplaced, that the universe may endure for trillions of years. Yet it also implied that the whispers are not a passing glitch, not a temporary fluctuation. They are the natural state of existence, an eternal trembling, a reminder that reality is never as solid as it seems. Thus the scientists found themselves in a strange place, staring into the abyss, aware of the possibility of collapse, and yet confronted with the fact of endurance. The whispers, paradoxical as they were, seemed to say both things at once, that reality is unstable, and that its instability is the very reason it persists. When the sky refused to yield its answers, scientists turned to machines of imagination. Supercomputers, vast architectures of silicon and code, became laboratories for entire universes. Within their circuits, cosmologists spun models of creation and destruction, of galaxies clustering and dissolving, of space-time trembling with hidden energies. If the anomaly could not be explained by observation alone, perhaps it could be conjured in simulation, its ghost reborn inside equations. The process was monumental. To simulate a universe is not to draw a picture but to write its laws. Each run required input, the density of matter, the strength of gravity, the value of dark energy, the initial ripples of the Big Bang. Trillions of calculations unfolded every second, mapping the growth of stars, the web of galaxies, the silent expansion of voids. Researchers watched as virtual cosmoses bloomed and withered on their screens, each one a possible reality, a mirror to the one we inhabit. Again and again, they sought the whispers. Did any simulation produce the same flicker, the same restless pulse seen by telescopes? Most did not. Universes filled with uniform dark energy were too smooth. Universes governed by stable fields were too silent. But in certain rare combinations, when the vacuum was allowed to quiver, when dark energy fluctuated, when gravity bent slightly beyond Einstein's command, then faintly, hauntingly, the anomaly appeared. This was both triumph and torment. Triumph, because it showed that the mystery could emerge naturally from physics, not merely from human error. Torment, because each simulation that reproduced the whispers also predicted futures more fragile than any cosmologist wished to imagine. Some universes collapsed quickly, torn apart by their instability. Others expanded into emptiness so complete that even atoms unraveled. And yet, there were models where the trembling persisted indefinitely, a cosmos forever humming, forever unsteady, yet never falling. In these, the anomaly was not a flaw but a feature, the natural music of existence. Reality, in such visions, was not still but vibrating, not stable but enduring precisely because of its instability. As the simulations multiplied, one truth grew clear. The anomaly could not be dismissed. It was not a glitch of machines or a quirk of noise. It was something that even universes of mathematics could whisper into being. And so, in the hum of processors and the glow of digital stars, humanity began to glimpse the possibility that the mystery was not outside us at all. It was written into the very code of reality. Science is the art of measurement, but the anomaly resisted every ruler, every clock. And so the conversation began to drift into older territory, the realm of philosophy, where numbers dissolve into questions of meaning. What if the whispers were not only a phenomenon to be studied, but a message to be interpreted? For centuries, humanity has wrestled with the silence of the universe. The stars shine, but they do not speak. The galaxies swirl, but they do not answer. The cosmos, immense and indifferent, has always seemed mute to our longing. And now for the first time there is a murmur in the silence. Could it be chance? Could it be error? Or could it be something more? The universe, in its own way, revealing that silence was never empty after all. Philosophers of physics asked, what does it mean for reality itself to tremble? If the anomaly is the song of quantum fields, then the ground beneath existence is alive with motion, restless and uncertain. If it is the footprint of another universe, then our cosmos is not solitary but part of a grander multiverse, infinite and strange. And if it is dark energy flickering, then the fate of everything we know is bound to a ghost we cannot see. Each possibility carried with it a reflection on human existence. If the universe is unstable, then so too are we, temporary configurations of matter balanced on borrowed time. If other universes exist, then our story is only one among countless others, no more central than a grain of sand on an endless shore. If dark energy itself is alive, pulsing through the void, then perhaps reality is not a static machine but a living ocean, vast and unknowable. The anomaly became a mirror. Scientists, gazing into its riddle, found themselves staring at their own fragility, their own yearning for certainty in a cosmos that offers none. The whispers seemed to say, the universe is not built for comfort, but for wonder. It does not guarantee safety, but it offers mystery. And in that mystery lies meaning not given, but made. Thus the line between physics and philosophy blurred. The anomaly was no longer just data, it was an invitation. An invitation to reconsider what it means to exist in a universe where silence is never truly silent, where stability is never absolute, and where the deepest truth may be that reality itself is always in motion, always trembling on the edge of the unknown. From the cold corridors of observatories to the supercooled tunnels of particle colliders, the anomaly spoke with the same chilling implication. The universe itself may be fragile, and if the cosmos trembles, what of the small, brief species that calls a single planet home? Humanity began to see its own reflection in the mystery, delicate, temporary, held together by conditions as precarious as those that bind space-time itself. The Earth orbits in a narrow band where life can endure, neither scorched by proximity to the sun nor frozen in its absence. Our atmosphere is thin, our biosphere fragile, our civilizations balanced on technologies that can falter in an instant. We are, like the universe we inhabit, perched on an edge. To hear whispers in the void that hint at instability is to be reminded of our own. The scientists felt this weight keenly. In their equations, they saw more than physics, they saw a parable. The anomaly might never destroy us. It might remain a mystery folded into the background hum of existence. Yet its presence revealed a truth that could not be ignored. Security is an illusion. The cosmos itself is not guaranteed to remain as it is. Why should human life expect more? And yet, there is another side. Fragility does not always mean weakness. Just as a crystal shatters easily yet dazzles with beauty, humanity's impermanence grants it meaning. To exist on borrowed time, under uncertain laws, is to find significance not in permanence but in presence. The whispers of the anomaly may be unsettling, but they also remind us that to live is to stand inside mystery, to flourish briefly against a background of infinite silence. In this way, the anomaly became more than a puzzle for astrophysicists. It became a meditation for all of humanity. We live in a universe that may be trembling, unstable, restless, but it is this very restlessness that allows stars to burn, planets to form, and consciousness to arise. Our fragility is not a flaw but a feature, the signature of a cosmos that is alive with change. And so the scientists, staring at the impossible signal, felt not only fear but reverence. If the universe is fragile, then every moment of its endurance, every heartbeat of existence, is a gift. The whispers do not only warn us of uncertainty, they invite us to cherish the delicate miracle of now. The whispers in the void were no longer dismissed as noise. They had become a frontier, and frontiers demand explorers. Around the world, agencies and institutions poured their attention into the enigma. NASA, the European Space Agency, Japan's JAXA, and countless observatories joined in a silent pact. Whatever the anomaly was, it would not be ignored. At NASA's Goddard Space Flight Center, teams refined instruments designed to filter out the faintest distortions in cosmic light. The Hubble Space Telescope was given extended time on fields where the anomaly pulsed most strongly. Meanwhile, the James Webb Space Telescope, humanity's newest eye, took its place as the keystone. Its infrared sensors could peer further into ancient time, capturing light born when galaxies were still in their infancy. Other missions were mobilized. The Dark Energy Survey, already tasked with mapping the cosmic web, redirected resources towards searching for patterns that echoed the anomaly. The European Space Agency's Euclid telescope, launched to probe dark matter and dark energy, became central. Its instruments, designed to chart billions of galaxies, were suddenly tasked with something far stranger, listening for the universe's hidden hum. On Earth, projects expanded. Radio arrays across deserts scanned vast swaths of sky for faint pulses. Neutrino detectors buried in ice and water were reanalyzed, in case ghostly particles accompanied the whispers. Particle physicists re-examined collider data, hoping to catch glimpses of the same instability at subatomic scales. Even gravitational wave observatories like LIGO and Virgo adjusted their algorithms, asking whether the anomaly could masquerade as faint tremors in spacetime. The work was exhausting, but a new sense of awe filled the community. This was not the pursuit of a distant black hole or an exotic planet. This was an attempt to pierce the veil of reality itself, to test whether the universe is as stable, as permanent, as we assume. And so, day by day, mission by mission, the hunt pressed forward. Each photon captured, each particle traced, each dataset refined, all were steps toward understanding. Science had never been so united by something so undefined. The anomaly was not only a question of physics, it had become a shared quest, binding nations and generations of researchers in the pursuit of an answer the universe had been hiding since its birth. The sky, once silent, was alive with instruments. Humanity was listening harder than ever before, and the cosmos, for reasons still unknown, had begun to whisper back. The present instruments strained against their limits, and so attention turned to the future. If the whispers of the anomaly were real, then new eyes, sharper and wider than any before, would be required to unveil its face. The next generation of telescopes and detectors became not only projects of science, but promises to the mystery itself. Foremost among them was the Nancy Grace Roman Space Telescope, NASA's great heir to Hubble. Its wide-field vision would survey vast portions of the sky, mapping the distribution of galaxies with a precision unimaginable decades ago. Roman was designed to probe dark energy, but now its mission seemed more profound, to catch the restless vibrations of a cosmos that might be alive with hidden tides. In Europe, ESA's Euclid mission soared outward, tasked with tracing the cosmic web in 3 dimensions. Billions of galaxies would be catalogued, their shapes and distances recorded in the hope of revealing the fingerprints of invisible forces. If the anomaly was bound to the skeleton of dark matter or the restless flow of dark energy, Euclid might glimpse its pattern written across the heavens. On Earth, the Vera C. Rubin Observatory prepared to open its eyes. With its immense mirror and sweeping survey of the southern sky, it would capture the flickers of transient events, the shifting light of stars, and perhaps the elusive pulse of the anomaly itself. Its data stream would be a torrent, billions of objects catalogued and compared, each one a potential clue. Other dreams stretched further. The Square Kilometre Array, the world's largest radio telescope, would turn deserts into ears listening for the faintest murmur of the cosmos. Future gravitational wave detectors, like the Einstein telescope in Europe and LISA in space, promised to listen to space-time with a sensitivity never before imagined. If the anomaly was not light but vibration, these instruments might hear its true song. Each new mission carried with it a sense of reverence. They were not built merely to measure, but to testify, to bear witness to the unknown. Together they formed an orchestra still assembling, an ensemble preparing to play the score of the cosmos. For now, humanity waits, poised at the threshold. The present whispers may be faint, elusive, but the future promises clarity. When Roman, Euclid, Rubin, SKA, and LISA rise fully into their roles, the sky itself may open, and in that opening, the anomaly, ghost, prophecy, or truth may finally reveal its name. But what if the instruments fail? What if Euclid, Webb, Roman, Rubin, the colliders, and the radio arrays all return the same answer? Silence that refuses to explain itself. This is the haunting possibility that the anomaly remains, stubborn and unresolved, defying every theory, every model, every attempt to pin it to the laws of physics. Science is built on the promise that mysteries yield to measurement, yet here was a phenomenon that deepened with every observation. What if no explanation fits? What if the anomaly is not a doorway to new understanding, but a reminder of the boundaries of human reason? Some scientists argue this is inevitable. Physics, they say, has reached a point where nature's secrets may lie forever beyond experiment. The universe may possess layers too vast, too subtle, too entangled with infinity for finite minds to untangle. The whispers in the void may be the shadows of truths we are incapable of perceiving. Others resist this thought. They insist that patience, ingenuity, and new tools will prevail, as they always have. There was a time when black holes were only speculation, when gravitational waves were only mathematics, when the cosmic microwave background was mistaken for noise. Each mystery, once impossible, eventually yielded. Why should this one be different? And yet, in the quiet between optimism and despair, a deeper reflection emerges. Perhaps the anomaly will never fit any single theory. Perhaps it is not meant to. The cosmos may not be a machine built for human comprehension. Its whispers may not be answers at all, but reminders that reality is larger than language, larger than equations, larger than the grasp of thought. If no explanation ever comes, the anomaly will remain not as a failure of science but as a companion to it, a constant hum in the background, a note of humility woven into the song of discovery. It will remind us that even as telescopes sharpen, even as theories grow bold, there will always be mysteries that elude us, horizons that recede as we approach. And perhaps that is the point. Perhaps the anomaly is not here to be solved, but to teach that wonder endures even when certainty does not, and that the greatest discoveries are not always answers, but the questions that refuse to die. In the end, the anomaly became more than a problem of physics. It became poetry, a trembling reminder that the universe is not a solved equation, but a living enigma. The scientists, weary from their calculations, began to speak of it in metaphors. Some called it a hum, others a heartbeat, others still a ghostly breath drifting across eternity. It was data, yes, but it was also art, a pattern that stirred awe precisely because it refused to be contained. The poetry of uncertainty is that it mirrors the human condition. We, too, are temporary beings, brief sparks in the dark, surrounded by mysteries we cannot master. To hear the cosmos whisper in ways we cannot explain is to feel kinship with the stars themselves. Just as the anomaly resists definition, so too do we resist reduction. Life, like the universe, is not a puzzle to be solved, but a story to be lived. For philosophers, the anomaly evoked timeless questions. Is meaning found in certainty or in the acceptance of mystery? For artists, it became an image, a brushstroke of silence across the canvas of the sky. For scientists, it was both burden and gift, the data that mocked their equations and the inspiration that pushed them to imagine new ones. It reminded humanity that science is not about conquering the unknown, but about walking within it. Every solved equation opens a deeper abyss. Every discovery reveals a greater ignorance. The whispers from the void were not an endpoint, but a beginning, a verse in a song that will never be finished. And perhaps that is beauty itself, that we are part of a cosmos too vast to comprehend, and that within its silence there are notes meant not for understanding but for wonder. The anomaly is not a threat, nor a promise, but a poem written in the language of the stars, read only by those willing to listen without demanding certainty. In its refusal to resolve, the cosmos gave us something greater than answers. It gave us the poetry of uncertainty, the mystery that nourishes imagination, the silence that hums with infinite possibility. The story of the anomaly closes not with certainty, but with silence, a silence now known to be alive with questions. From the first faint whispers detected by NASA's instruments to the grand debates of physicists and philosophers, the journey has led not to resolution, but to reflection. The cosmos has not surrendered its secret, it has only deepened the mystery, wrapping it in echoes that stretch across space and time. What remains are eternal questions. Is the anomaly a signature of dark energy, restless and alive? Is it the trembling of quantum fields, the breath of the vacuum itself? Is it the scar of a universe balanced precariously in a false vacuum, waiting to collapse into another reality? Or is it the faint touch of other universes, brushing against ours in the quiet of infinity? Each possibility lingers, none complete, all equally wondrous and unsettling. Yet perhaps the truest meaning lies not in answers but in perspective. The anomaly reminds us that the cosmos is not a finished book, but a manuscript still being written, its pages boundless, its ink mysterious. To exist within it is to dwell in uncertainty, to live as both observers and participants in a story larger than imagination. For humanity, the whispers carry a lesson. We are fragile, brief, and yet capable of wonder. We are not masters of the universe, but children of its silence, listening for notes we may never fully understand. And still, we listen because listening itself is part of what it means to be alive. So the anomaly remains, unexplained, unresolved, a mirror held up to our longing. In its presence, we see not only the trembling of the universe, but the reflection of our own trembling hearts. It is a question without end, and perhaps that is its gift. And now, as the story fades, the pacing slows, the words soften, the final images linger like the last light of a dying star. The universe continues, vast and silent, its fabric humming with secrets too deep to name. Galaxies drift, stars burn, atoms dance, all against the backdrop of a mystery that refuses to be silenced. The anomaly is still there, woven into the night sky, a reminder that existence is both fragile and infinite. Sleep now, with the stars overhead. The cosmos will keep its watch, whispering softly in the language of eternity. The questions will remain, waiting for tomorrow, waiting for the next listener who dares to dream.